Hi, in this video I want to talk about the TVR valve, the thermostatic radiator valve on your heating system, what you should do at the end of the heating season and the start of the heating season, some of the fixes that are on offer, and also I want to take this apart. So the first thing is the care instruction. Basically, a TVR valve restricts the flow of water. It's an analog device designed to measure the temperature of the room and restrict the flow of heated water accordingly into the radiator until there's an equilibrium. The idea is that your temperature of the room will be held steady and the radiator will only supply as much heat as is necessary to keep the room at that temperature. And it does that by essentially restricting the flow. Let's go through the care instruction. For the first time in about 19 years, it went faulty on me, but I've never had a problem up until recently, and the only reason that I did have a problem is that I didn't follow my own advice, which is what you should do at the end of the heating season. End of the heating season, you turn it to max. So you can see it's on max. You can see this thing, it goes from 6 all the way down to 0, and you just turn it to 6 and preferably slacken the locking mechanism for the head. It comes in two parts. You have the head and you have the body here. You can slacken this so that the head itself comes away. Generally when you buy these you get the thermostatic head and you've got what they call a decorator's cap, and that just goes on top of that, and you can manually push the tap part of this to close it off or open it up. Most people, they don't have this, or when they bought the house it didn't come with that, or it's been lost for whatever, so you need this part of that. Some of these thermostatic heads have locking points where you can actually lock the range so that people can't dial it all the way up or dial it all the way down. You would have to refer to your instructions really to undo that, but generally you just turn it all the way up. If the radiators are coming on, then the issue that I'm going to describe next really just doesn't happen. So I'm taking this off. At the start of the season, really what you want to do is just make sure this is working. The best way is to just push this pin up and down and make sure it moves. This is a valve and it's normally open, and by pushing this down, up and down like so, you can do it with, I've got a teaspoon. It only moves a tiny distance, 3mm to 5mm, like that. If it moves quite freely, then that's absolutely fine, but often what you'll find is it gets stuck. Now, what I was doing there was pushing down with the teaspoon like this, and I have on one occasion slipped and caught my finger on this pin, and it was quite painful. So I would suggest that if you do something like that, you use the spoon this way so that the thumb is properly protected if you're using your thumb, or the other way, again, it's properly protected. This is quite a stiff pin, but it's not so stiff that you couldn't use a random piece of plastic to push it. But as I said, protect your thumb or your finger or whatever you're pushing down with. Just go up and down. If it goes up and down quite easily, then you can just put the head back on and set it. Another thing I would suggest, that if you're messing about with the head and turning up and down, because of the nature in which it works, if you find that the room is exactly right before you touch the head, then remember the position of the head. Write it down somewhere. 3 is considered room temperature. These are just numbers, and although they do give an indication of temperature, they're not exact. It is best to remember, so if a particular room is on 4, write it down so that when you do put these back, they're fine. If I take off my head, I've just took the head off by using this locking collar here. Some of these have different ways to be taken off, in which case then you need to refer to your instructions on that particular make. Things to note. You'll notice that there's a little pin in there. You see this little pin here? It's just loose. It just drops back in. The body is what they call normally on. There's quite a stiff spring there. If I turn this down, you'll see that that pin doesn't retract as much, and if I turn it up, hopefully you'll see that it kind of moves back in to the body. So doing that, let's turn it back. So it's in at the moment and I will turn this up and you'll see it comes out. So when I say up, I mean turning it down, so I'm turning it to 0. If the pin is sticking out like that and you try and put this back on, it's nearly impossible to put back on. If the pin's sticking out, turn it all the way up as high as you can go and it should go back on quite nicely. So if the pin's sticking out, you've got the head set like that. We'll talk about how these things work. We've talked about the care instructions. This is a diagram of the thermostatic radiator valve, and I split it into two parts. You've got the head, this thing, and we have the body, which is this part here. Let's look at the head to start with. And I can't disassemble this because I'm still using it and it's still valid even though it's quite old. No point throwing it away because it works perfectly. There's a capsule in there, there's a metal thing, and we have a locking collar, and you saw that there was this pin that seems to be loose, and the whole thing winds up and winds down. So let's look at what we have there. This is a sort of simplified copy of that. I've got my point here, that's that thing I've got here. This is the head, and this blue bit here is something to put it on hand tight. That's another important thing. If anyone tells you to use grips for putting this back, that's wrong. You should never use grips. This is designed to be used by hand only, not with grips. So grips will potentially damage it. So hand tight only. Now I've got the capsule in here, and the capsule is this item, and the green dots within it represent the fluid that's in this. I've heard of these having wax. I'm not aware of any that I know, but apparently they do exist. But this is a liquid capsule, and this section here is an internal structure which is like an accordion section, and that allows this liquid to expand and push on that pin. But in there is also a spring, an extremely stiff spring. You've got this part here which is just plastic, that's this black part here, and you'll see that there's, I don't know if you can, whether it's clear, there's holes in it, and that's to allow air to move through the bottom here, and that's not so that it can go up into the capsule, that is just so that this part is kept as cool as possible, because the capsule wants to pick up the air temperature of the room, not of the radiator or the central heating system. So the central heating system water is here, and of course there's going to be a natural conduction in this direction. So having plastic and there's little holes in there helps to stop that conducted heat going up and affecting the capsule. Similarly, so I've drawn a fairly simplified, because actually this white bit here is made of several pieces of plastic. It is there to stop radiated heat, so radiation from the radiator itself here, because again it's in close proximity, and there's holes in it, it's kind of like vents, and that allows the air through. This pin here, which is the thing you can hear, if I just hold this, you can hear the pin moving about. The capsule there, and if I turn this all the way down, you can see that if I push the pin, it pushes up against capsule. If I push down on the capsule, you'll see there's a movement there, and that tells you that this whole structure is not under tension. And so what does that actual spring do if it's not pushing? Because quite a few explanations say that that spring there is to return this accordion section. Air pressure alone is enough to do that. It's stronger than that spring, that's for sure. So what is this actually there for? That is because when I put this on and I turn it down to 0, I effectively, and if you watch carefully, you'll see that this will shorten as it turns down. You can see that there's kind of like a screw thread which I try to represent that jagged edge. That will push that tap part of it, which is this, which I'll talk about a little bit more in a moment, and that pushes that all the way down and shuts off the water supply, this particular area. Once that happens, there is no further movement, there's no slack for it to take up. But the forces that something like this, expansion and contraction, the physical forces that it can exert are quite tremendous. So much so that it's quite likely that if there was no way for it to take up that expansion and contraction, it would bust the plastic. So it would either bust itself out, or it would damage the plastic area here, or it will break something, possibly even the capsule itself. So that's what the spring does, it takes up, and that's why it's such a stiff spring. It has to be a lot stiffer than this spring here, which is the thing that holds this normally on. As I said, the forces are quite tremendous, the physical forces of expansion and contraction, which this uses. Let's try this out. Undo this. So let me close this off. And we'll talk about the failures for the head. Is that the pin is stuck down, is probably you haven't turned this to its maximum setting, so the pin is being pushed down. If the pin won't come down, then you could have lost liquid in the capsule, in which case it's throwaway time. Also, it could have busted out of its housing where it holds the capsule in place. It could have busted the pin or busted the spring, and again a replacement of the module. So it is possible for the spring to bust, not heard of that. Again, same with the pin, it's just plastic, this particular pin. Getting another head from the same manufacturer, well, they do seem to be matched. The movement between this, as I said, when you're pushing it down, is between 3 and 5 millimeters, and they're different heights. So just because it fits doesn't necessarily mean it's right for the particular body. So the head and the body tend to be matched for the manufacturer. So if I had another head of this same manufacturer, then I could probably use it. But if I don't have a head, then it's touch and go whether or not it's worthwhile trying to replace the head. These are fairly cheap, and they're not actually that difficult to replace, so I would say probably better off replacing it if you can. And we'll talk about the body part of it. This is the bit that usually breaks, this part here. In my particular case, I did have a problem where I loosened it up, and that was good enough, that relieved it. What is actually, we talk about the capsule here, and you can see here I've got my valve part, and the red bit here represents the metal body that you can see there, and it sits on what is called a seat. The green here represents the cartridge, which is brass in this particular case, and this blue bit here is a packing gland type thing. And in this particular case I've drawn a sort of a couple of O-rings, because there's usually 2 O-ring seals. This red thing here is a pin, which is the steel pin that you can see poking up here, usually stainless steel, and that actually just sits on top of the valve mechanism, and it's not physically connected. Again, this helps to stop conduction going up this way, but if you try and turn or pull this, because it's not connected, you don't really affect what's happening here. When I take this out, which I shall do now, this is a live system. This is actually a running system at the moment. I've switched the boiler off. Because this is actually on a zone, I've switched the zone out, so the zone is out of the heating system. That's taken away the expansion vessel and the like. I've gone to each of the other radiators, and I've turned off the thermostatic radiator valve, and the other side, the lock shield side, I haven't touched on those particular ones. On this particular radiator, because I'm going to be accessing this, I'm going to have to turn off the lock shield end. The lock shield end usually has a lock shield head, like that. And when you buy a radiator valve, they come with 2 heads. So this is a radiator valve, as you can see. It comes with 2 heads, lock shield head and the tap head. And the lock shield head is probably because if you have 2 heads, one on one side and one on the other, you always go for the one that you can turn. So if you turn the radiator valve, then you just turn on and off the radiator or restrict the flow but the lock shield end is used for balancing. So when I fully turn this on, the balancing should allow all the radiators to come on together. For this to work properly, your radiators must be balanced, but the problem with balancing is that if you ask 5 different plumbers how to balance a system, you'll get 5 different answers. I'm not going to go into balancing in this particular video because it will just make it massive, but the lock shield end on this particular radiator, I'm going to just put this on and I'm going to close that off. Now it's just the water in this radiator plus the feed side, and the return side and all the water in the other radiators is now separate, so I've got 2 halves to the water. Next thing I want to do is I want to just take out the pressure in this particular radiator. Now usually you would do that from the bleed screws, but in this particular case this radiator has a drain point, so I'm going to use the drain point. So that's drained it, so that's taken up that expansion. And that's going to allow me then to take this out without too much drama. So you can see this is a brass top, so what I'm going to use is, so this is a 19mm socket I'm going to be using on this, and that's only so you can use a box spanner or something like that to make sure that the pressure is equal on all of those. I'm going to use this. Now I'm turning it in this dimension, which means the torque's in that direction, and I'm not going to be putting any pressure on the pipe work. I'm not going to be unscrewing that. It's going to be turning, at the moment it's going to be turning about the radiator, and the radiator's quite strong, so I shan't be putting this under any pressure. Don't do this. If you break your central heating system, it could be thousands of pounds to put it back together again. But I'm doing this really just for interest on how these things work, as opposed to a how-to-do video. Let's take it inside this then. So I'm going to at least support this on the centre. I'm not pushing down, I'm pulling. And that should have done it, that's released. Oops. I should take this out. So there's the valve. You can see the pin sticking up. Let's see if I can. Right. You can see that's pushing out. So all that's doing is pushing down on that tap there, which is this tap here, and it's pushing against that seat. So that's how it's restricting the flow. So in theory, I could use something like this to reseat it if it was necessary. Now, generally this is normally on, and as I said, it's an analog device. It restricts the flow. It's not like a thermostat where it reaches a threshold and then it either operates something or switches something out. This reduces the volume and the speed of flow. Right. Let's see if I can use this. This is just a tap reseating tool. So I think it's a small head. That's the cutting blade. With this thing, the way it works is, let me just quickly check. You can see that this is the correct one for this. So if I make this up, this is a reseating tool, and I can put then this into here, making sure that it goes in correctly. Because the thing about the reseating tool is it's important it goes in absolutely perpendicular to the mounting position. I'm not going to turn this because there's absolutely nothing wrong with this seat, but it just shows that if you really wanted to and you had to, you could actually use the reseating tool to reseat this, because it's a tap just like any other. So I'm not going to do that. I think if I had to reseat one of these, I would actually physically take this off, because the last thing I want is debris or swarf actually in the central heating system. That would be another big disaster. So anyway, it's interesting, prove the point. So let's put this back. Clean. Oh, there's another O-ring here, which I didn't have on my diagram. Right. I did actually check this, and I noticed that this is only about maybe a 16th or 32th of a turn. So you don't want to brutalise this, just put a tiny amount to put it back to how it was. And that's about that much. That's done. I've talked about the actuator, pin stuck in, pin stuck out. The body, you can move this up and down. Sometimes there is potential that you might get debris stuck behind this. Operating this when you're using the flow of the water to wash the debris away out of that position. I've had these going 19-20 years without issue. So hopefully I'm going to get many more years. The only thing that's really wrong with this, you can see that the plastic has gone yellow. That's something which I'll try and rectify in another video. So let's put this back on. So as you see, there's no need to use pliers or grips on this. Hand tight is sufficient to put this on. The mechanical advantage of the locking ring, which I've drawn in blue on this, is easily sufficient to put it on. No need for grips, don't use grips. The pin itself that you can pull on isn't necessarily connected onto this. It isn't a single shaft all the way through. So pulling on this could cause the pin to come out, and in which case you'll have water leaking out from the central heating system through that hole. This has happened to a friend of mine, and he said just pushing the pin back in was enough to fix that. But in his particular case, all of them, they started to fail through this point. One of the things that has been recommended is to use WD-40 on that particular area. Now, I would say that's quite questionable. You've seen the internals of this. The idea that you would spray WD-40 here and it would somehow get all the way to here, because as I said, it's normally on, so the spring is always pushing this up. The only way that this can be pushed down to get stuck there is for this to be turned, because it's now summertime. The temperature of the day and night is quite high. You have it set to, say for instance, 20 degrees, and in the house it's 25 or 27. In the night it's probably not far off either. Of course it's permanently pushing down on that, and if you push hard enough on rubber, often it sort of changes its properties and it goes from being elastic to plastic, and that can cause the rubber to then stick to the seat, in which case of course the pin's stuck. So putting WD-40 in I don't think is a good idea. It does say that on WD-40's website that you can do that, but these O-rings are butyl. Now there is a suggestion that actually WD-40 won't affect those, but if they're not butyl then it possibly could. So I would say don't use WD-40. One of the things that you can do to release that is to tap it, and that would be to just take the head off and then tap it, and hopefully that vibration along with the relatively stiff spring down here will cause it to release and pop up. So anyway, I think that covers pretty much everything. So thank you for watching. This is a long video. I think hopefully with some editing I'll be able to cut this down. The water's looking relatively good on this. I think maybe a flush is in order. Thank you for watching, and I hope this has been some help to you.